That noise you heard this morning during startup, the one you told yourself was just twin cam character. A $47 part is failing inside your engine right now, and every cold start brings you closer to a $2,400 top-end rebuild. 10 symptoms that mean trouble is coming, and number 1 reveals why Harley potted their stators in resin to block the exact aftermarket fix that would expose their 340% markup. Number 10. The cold start knock dealers ignore. 30 seconds after you hit the starter on a cold morning, you hear it. A hollow tapping from somewhere inside the top end. Not the normal twin cam rumble. Something sharper, something that fades once the oil warms up. You mention it at your next service and the writer tells you that is normal break-in character. He is lying to you. That sound is your cam chain tensioner beginning to fail. The tensioner shoe is a $47 part made of plastic composite that wears down gradually against your cam chain. When it is fresh, it keeps constant pressure on the chain, eliminating slack. When it starts to go, you get that hollow knock at startup because cold oil has not yet pressurized the hydraulic tensioner enough to take up the slack the worn shoe can no longer handle. The service writer knows exactly what that sound means. He also knows that if he documents it as tensioner wear, it becomes a warranty claim he has to process. If he writes normal operating characteristic, you ride out of there thinking your bike has personality. Tech Josh S., who works twin cams and Milwaukee 8s, told his Facebook group exactly how this plays out. His words: "You all keep riding until it starts knocking like a diesel, then act surprised when I tell you wiped out your tensioners. The preventative fix runs $600 to $800 for a proper tensioner upgrade kit with labor. The repair after the tensioner fails completely and scatters debris through your cam chest costs $2,500 minimum, often more when that debris scores your cam bearings." Indian eliminated the cam chain tensioner entirely on their Thunderstroke motors in 2014. Harley knew about this design weakness for years. Internal engineering memos acknowledged the failure pattern. They calculated warranty exposure against the cost of a redesign and decided your rebuild was cheaper than their retooling. Number 9 shows you exactly how your transmission fluid proves another design flaw they chose to ignore. Number 9. Transmission fluid that tells the truth. Pull your primary drain plug at 12,000 miles and hold a magnet to whatever comes out. If that fluid sparkles under a shop light, you are looking at evidence Harley buried in their own engineering documents. That metallic glitter is not normal wear. It is your compensator sprocket slowly grinding itself apart. The compensator sits between your engine and transmission, absorbing the power pulses from your twin cam or Milwaukee 8 before they hammer your primary chain. Harley designed it with steel sprocket faces that mate against a spring-loaded shock absorber system. The problem is, those steel faces wear against each other every single time you crack the throttle, and the debris ends up suspended in your primary fluid. Indian looked at this exact problem when they developed the Thunderstroke platform and engineered it out completely. Their primary drive uses a different compensation system that does not generate the metal contamination Harley owners treat as normal. That was 2014. Harley knows about this. Their own internal engineering assessments documented the wear pattern and calculated the warranty exposure. The math worked in their favor. Compensator failures typically happen outside the 2-year warranty window, which means every replacement is a customer pay job at $800 to $1,200, including labor. The tell is in your fluid. Clean primary oil at 12,000 miles means your compensator is holding up. Glitter means you are on borrowed time. A $50 fluid change with inspection catches this early. Dealer Tech Steve at a Midwestern dealership described pulling primaries apart on bikes with 70,000 miles and finding the compensator sprocket worn to half its original thickness. The owners never knew because they never looked. Number 8 exposes a calibration error Harley buried in a technical service bulletin that most dealers have never even opened. Number 8. The warm weather surge nobody admits. Above 85 degrees ambient temperature, your Milwaukee 8 starts doing something strange between 2200 and 2800 RPM. A hesitation, a surge. The engine pulls, then stumbles, then catches again. You roll on smooth throttle, and the bike jerks like it cannot decide whether to accelerate or coast. Bring this to your dealer and watch what happens. The service writer nods sympathetically and suggests your throttle technique might need refinement. He will recommend a fuel system cleaning at $189. If you push back, he might offer a reflash of your engine control module for the same price. What he will not tell you is that Harley issued Technical Service Bulletin M8 R00142, documenting this exact symptom as a heat-soak calibration error in the factory fuel mapping. The Milwaukee 8 runs hot by design. Those 4 valves per cylinder and the integrated exhaust system create a heat signature that climbs rapidly in slow traffic or high ambient temperatures. When intake air temperatures spike, the factory calibration does not compensate correctly. The engine management system leans out the mixture in that specific RPM range, causing the surge you feel through the seat. BMW solved this on their Boxer engines with an adaptive fuel mapping system that adjusts in real time based on intake temperature sensor data. Harley has the same sensors. They simply did not program the adaptive response into the base calibration because it would have required additional development time before the Milwaukee 8 launch. The TSB fix should be warranty on any affected model. Dealers are trained to position it as a customer pay service unless you specifically reference the bulletin number. Even then, some writers will claim your VIN does not qualify. It does. The bulletin applies to all Milwaukee 8 touring models from 2017 forward. We are halfway through this list, and number 5 is where owners lose the most money through pure misinformation. Stay with me. Number 7. Brake lever creep that predicts catastrophe. You pull up to a stoplight and squeeze your front brake lever to hold position. 30 seconds later, the lever has moved closer to your grip without you releasing pressure. Another 30 seconds and it is almost touching the bar. Your first thought is air in the lines. You are wrong. This is master cylinder bore scoring, and it predicts a brake failure that can kill you. The master cylinder on your Harley uses an aluminum bore with a rubber piston seal that slides back and forth every time you squeeze the lever. Over time, contamination in your brake fluid creates microscopic scoring on that aluminum surface. The seal can no longer maintain pressure against the scored bore, so fluid creeps past it under sustained load. BMW solved this problem in 2011 with a $3 ceramic coating process on their master cylinder bores. The coating prevents scoring and extends master cylinder life essentially indefinitely. Harley's purchasing department reviewed the same coating technology that year and rejected it based on per-unit cost increase. The fix on a Harley requires a complete master cylinder replacement. Dealer price runs $450 to $600 with labor for a job that takes a competent tech under an hour. The aftermarket sells rebuilt master cylinders with coated bores for $160, but most owners do not know they exist because the dealer parts counter will never mention them. The dangerous part is that lever creep progresses slowly enough that you adapt to it. You start pulling the lever harder, you adjust your grip, then one day you need emergency stopping power and the lever goes straight to the bar with nothing behind it. Number 6 reveals what your oil temperature gauge is hiding from you and why Harley documented the problem in a bulletin most dealers never downloaded. Number 6. The oil temp lie on your gauge. Your gauge reads 230 degrees. You think your engine is running warm but within tolerance. You are wrong by 57 degrees where it matters most. The temperature sensor on your Harley sits in the oil tank, measuring fluid temperature after it has circulated through the engine and had time to cool in the lines. It does not measure the temperature inside your oil pump cavity, where the gears that pressurize your entire lubrication system operate at peak thermal load. Internal dyno testing at Harley showed oil pump cavity temperatures hitting 287 degrees when the gauge displays 230. That is a 57-degree spread that cooks your pump gears from the inside out. Harley documented this in Supplemental Bulletin 489B. The bulletin was uploaded to the dealer technical system, but flagged as supplemental rather than mandatory reading. Most service departments never opened it. The failure mode it describes starts with accelerated gear wear inside the pump cavity, progresses to reduced oil pressure under load, and ends with bearing damage throughout your bottom end when the starved surfaces finally make contact. Indian positions their temperature sensor directly in the oil galley feeding the pump. Their gauge shows real operating temperature, not the cooled down number Harley displays. same sensor cost. Different placement decision. An external oil cooler with a bypass thermostat prevents this failure entirely. The part costs $180. Installation runs 2 hours at shop rate. The bottom end rebuild that follows an oil pump failure from heat damage starts at $3,200 and climbs from there, depending on what the debris took out on its way through your engine. Number 5 is where most owners get hurt financially, and the fix costs $12. Number 5. Clutch drag. The manual calls normal. Hot engine, neutral selected, and your bike still creeps forward like it wants to launch without you. Your owner's manual calls this normal clutch engagement characteristic at operating temperature. The service writer will tell you the same thing. Both sources are protecting a design decision from 1984. That forward creep is clutch drag caused by spring plate warping under repeated heat cycles. Your clutch pack contains spring steel plates that separate the friction discs when you pull the lever. When those springs heat up and cool down across hundreds of ride cycles, they lose their flat profile. Warped springs cannot fully release the friction discs, which means some power transfers to your transmission even in neutral. Victory fixed this in 2012 with a $12 Belleville washer stack that maintains consistent spring pressure regardless of heat cycling. The Belleville design uses conical washers that deflect under load rather than flat springs that warp over time. Harley's engineering team evaluated the same design for the 2017 clutch refresh and retained the 1984 diaphragm spring specification because retooling would have cost more than projected warranty claims from clutch drag complaints. The aftermarket sells Belleville conversion kits for $65. Installation requires pulling your primary cover, which the dealer labor guide books at 1.8 hours. A competent home mechanic does it in 45 minutes with basic tools. The drag you have been living with as a character trait of your bike disappears completely. Ignoring clutch drag accelerates wear on your friction plates and eventually scores your clutch basket. That repair runs $850 to $1,200. From number 4 forward, we are into the failures that cost serious money and the shop tricks that can save you hundreds. Keep watching. Number 4. Fork seal. Weep, they will charge you $600 to fix. A thin film of oil appears on your lower fork legs after highway miles. Not a puddle, not dripping onto your wheel. Just a sheen that tells you moisture and dirt will soon follow it past your seals and into your fork tubes. The dealer service quote comes back at $550 to $620 for a fork seal replacement. That quote is built on a lie hidden in the flat rate labor system. The Harley service manual documents fork seal replacement as a 3.2-hour job requiring complete fork disassembly, lower leg removal, and bushing inspection. What the manual deliberately omits is the seal driver shortcut that every experienced tech actually uses. With a $14 SKF seal and the right driver tool, a knowledgeable mechanic replaces your fork seals in 20 minutes without pulling the forks from the triple tree. The dealer cannot use that shortcut and bill 3.2 hours, so they do the full teardown even when the seals are the only failed component. You pay for bushing inspection labor you did not need on a bike with 18,000 miles and perfect bushings. The weep you see on your lowers is almost never bushing wear on a bike under 40,000 miles. It is seal hardening from UV exposure and age. The seal lip loses flexibility, can no longer conform to the fork tube surface, and allows oil past. A $14 seal and 20 minutes of your time fixes it. The $600 dealer quote includes $240 of unnecessary teardown labor built into the flat rate book, specifically because the shortcut method cannot be billed at full time. Kawasaki publishes the seal driver method directly in their service documentation. Harley buries it because the labor margin on fork service funds their service department's monthly numbers. Number 3. Exhaust header blue. That means lean death. Blue-purple discoloration creeping past your header flanges looks like a patina of hard use. What it actually reveals is an air-fuel ratio pushing 15.8 to 1 under load, well into detonation territory, where your piston crowns become the sacrificial component in Harley's emissions compliance strategy. Your Harley runs lean from the factory because EPA certification requires specific emissions targets at specific test points. Meeting those targets with the stock calibration means the engine operates at air-fuel ratios that prioritize catalytic converter efficiency over combustion chamber survival. Under sustained load, highway cruising at 75, or climbing a grade with luggage, those lean ratios generate exhaust gas temperatures hot enough to discolor stainless steel headers within a few thousand miles. The blue ring creeping up your header pipes marks exactly how far the heat damage extends. Each inch of discoloration represents combustion temperatures exceeding 1100 degrees at the exhaust port. That heat does not stay in the pipes. It radiates back into your cylinder head, raises peak combustion temperatures, and creates the conditions for detonation under load. Honda addressed this on their VTX touring platform with a closed-loop fuel injection system that monitors exhaust oxygen content in real time and adjusts fueling to maintain safe air-fuel ratios regardless of load conditions. Harley uses open-loop fueling under wide-open throttle specifically because it allows them to meet emissions targets at the test points without the cost of closed-loop hardware calibration across all operating conditions. A fuel management system with proper tuning costs $280 installed. It adjusts your air-fuel ratio to 13.2 under load, eliminating detonation risk and dropping exhaust temperatures by over 150 degrees. The piston damage that results from running the stock lean calibration for 50,000 miles costs $1,900 to $2,800 to repair, depending on how many cylinders need work. Number 2. The steering head click they blame on roads. One single click through your handlebars. You feel it over sharp pavement cracks or railroad tracks. Maybe a slight notch in the steering when you turn the bar's lock to lock in your garage. The service writer tells you bad roads cause that feel in every motorcycle. He is covering for a bearing design Honda abandoned in 1992. That click is bearing race brinelling, and it predicts steering head failure that will manifest as a wobble at highway speed with no warning. Your Harley uses ball bearings in the steering head, the same basic design specification from 4 decades ago. Ball bearings handle rotation well, but they concentrate load at single contact points. Every impact from the road surface drives those balls into the races, creating microscopic indentations called brinelling. Once the races are brinelled, the balls fall into those divots during steering input, creating the click you feel. Honda converted their entire touring lineup to tapered roller bearings in 1992. Tapered rollers spread load across a contact line rather than a contact point, eliminating brinelling entirely under normal use. The conversion costs Honda about $4 more per bearing, set at manufacturing scale. Harley's parts margin on the complete neck bearing service runs $890 at the dealer counter. That price requires the ball bearing design to fail regularly enough to maintain service revenue. Tapered roller bearing conversions from the aftermarket cost $65 and last essentially forever under normal riding conditions. Tex Steve at a Midwest dealership described the pattern. You start hearing it, a clunk every time you break your front brake. Owners come in with races just shot, notched so deep you can feel each position as you turn the bars. The conversion takes the same labor time as the factory bearing replacement. The only difference is whether you spend $890 on parts that will fail again or $65 on parts that will outlast the motorcycle. And now, number 1. This is the failure Harley engineered to be unrepairable without paying them. Number 1. The voltage drop conspiracy at idle. Watch your voltmeter at hot idle. If it dips below 13.2 volts, you are watching the opening sequence of a Stator failure that internal Harley warranty data shows hits 34% of 2017 through 2021 touring models, 1 in 3 bikes. And Harley designed the repair to be impossible without paying them nearly $1,900. The Stator lives inside your primary case, wrapped around the rotor that spins with your engine. It generates the alternating current that your regulator converts to direct current for your battery and electrical system. When stator windings begin to fail, output drops at low RPM first because the magnetic field cuts fewer windings per revolution. You see it as a voltage sag at idle that recovers when you rev the engine. The $89 Stator that fails is potted in resin inside the primary case assembly. Harley's engineers made this decision specifically to prevent the exact aftermarket replacement that would expose their parts markup. A third-party Stator costs $105. The Harley Stator assembly costs $360, but you cannot simply swap the Stator because it is encased in resin bonded to the case components. The complete primary side repair replacing the Stator assembly as Harley designed it runs $1,847 at average dealer labor rates. A repair that should cost $250 in parts and an hour of labor instead requires case splitting, assembly replacement, and realignment because Harley's engineers potted an $89 wear item in resin to capture the service revenue. The 34% failure rate appeared in internal warranty tracking data that surfaced during a 2019 legal discovery process. Harley's own numbers showed the Stator design failed at more than 3 times the rate of competitor units from Honda and Yamaha touring platforms. The engineering response was not to redesign the Stator, it was to extend the resin potting process to make field replacement even more difficult. That voltage dip at idle is your $1,800 warning. An external voltage regulator test costs nothing and takes 2 minutes. If your system shows charging weakness, an independent shop can source aftermarket Stator assemblies with serviceable designs for $420 total. The dealer will never mention this option exists. That covers 10 warning signs your Harley is sending right now and the exact dollar spread between catching them early and riding them into catastrophe. If you have experienced any of these symptoms, drop it in the comments. Subscribe for more content exposing what your dealer will never tell you. And check your voltage at the next stoplight. Ride safe out there.